Hi guys, welcome again to our MPLAB XC8 tutorials for Absolute Beginner series. This is tutorial 38. We're gonna continue with our I2C bus tutorials. In the previous tutorial, we learned how to configure the I2C bus with MPLAB Code Configurator. We explained the I2C functions generated by MCC, but we did not write any code. In this tutorial, we're gonna be a bit more specific. We're gonna learn the I2C on a component on the TC74, a simple temperature sensor that works on I2C communication protocol. We're gonna use MCC to read and write data to this sensor. In the next tutorial, we're gonna go even further by looking at the popular DS1307 real-time clock. Temperature sensors are very important in many electronic devices. The TC74 is a serially accessible temperature sensor. It's particularly used in low-cost and small form factor applications. These are some of its features. It outputs as an 8-bit digital word. It works on I2C bus. The supply voltage is from 2.7 volt to 5.5 volt. Basically, it's got two models, the one that works on 3.3 volt and the other one that works on 5.5 volt. You can use it in many different applications, like in thermal protection for hard drive and other PC peripherals. You can use it as a low-cost thermostat control. You can use it in power supply, or you can just use it as a replacement for a thermistor. The temperature resolution is 1 degree Celsius. The conversion rate is a nominal 8 samples per second. The small size, low install cost and ease of use make the TC74 an ideal choice for implementing thermal management in a variety of systems. So these are the packages that you can find this component in. You can find it in TO220 or STO23. If you need PC board or surface mount technology assembly, you can consider PCBWay, a Chinese-based PC board prototyping and assembly with great quality at a very low cost. Now they are running a special for SMT order for only $30 US, which include also free worldwide shipping and free stencil. This is really cheap, so don't miss out of this opportunity to check out the quality of their services. They could potentially be the manufacturing partner that you are looking for to develop your electronic product. It's very easy to place an order with PCBWay. Just need to fill out this form and upload your Gerber files to place your order. For more information and to place an order, please click on the link in the description of this video that will take you to their website. The circuit diagram of this project is going to be very simple. You can virtually use any PIC that is supported by MCC. In this tutorial, we're going to use the PIC 18F 45K22. Then we're gonna need the TC74. This is a temperature sensor with I2C interface. We're gonna also need some few resistors. We can also need the push button to reset our circuit. We're gonna set the I2C pull-up resistors to digital model type, as the signals going through them are going to be purely digital. The sensor clock pin is gonna be connected to the PIC RC3, which is serial clock pin, and the SDA is gonna be connected to the PIC SDA1 pin. And we're gonna connect this pull-up resistor to this I2C bus line. We can also need a serial terminal to display our temperature values. We're gonna use the virtual terminal. Let's start quickly a new project in MPLAB XC8. Open MPLAB Code Configurator. Gonna configure the system module. We're gonna use the internal oscillator. Gonna set it to 8 megahertz. We're not gonna use low voltage programming, and we're gonna disable the watchdog timer. The next thing, we're gonna set our I2C peripheral under the MSSP. We're gonna use the first MSSP. You can see we've got two library options. You can either use the Foundation Services library, or we can use the generic PIC 10, PIC 12, PIC 16, and PIC 18 MCUs. If you need more information about these libraries, how to use them, you can just click on this help button. This is a short description of this library. If you click on external links and click on wiki, it's going to take you to microchip developer help page. Here as well you can learn more how to use this peripheral. The Foundation Services library is more abstract. As you can see, it gives you only the basic functionality of this peripheral. So you can just enable the I2C or the SPI. It does not give you the freedom to configure your peripheral in its finest details. You can use this library if you don't know much about the peripheral. You just need the functionality added to your application. As you can see, it's very simple to use, but the drawback of this library is less beginner friendly, even though it's supposed to be simpler to use. If you click on generate project header files, I2C driver H, you can see this library is not documented, and there are no examples on how to use these generated functions. So it's gonna really be difficult for you to use it if you've never used it before. So we're gonna remove this one. On the other hand, the generic PIC 10, PIC 12, PIC 16, and PIC 18 library. In the easy setup, you can select the peripheral that you're gonna use. I2C master in this example. We're gonna enable the MSSP. The slew rate, we're gonna set it to standard speed. The I2C clock frequency, we're gonna set it to 100 kHz or below. And the slave address is gonna be a 7-bit address. In the registers window, it gives you the possibility to directly set up the registers in its finest details according to your requirement. For us in this example, the easy setup is going to be enough for this application. Click on generate. We're going to check our header files again. I2C1.h. You can see at least now we've got some descriptions of these generated functions. Enum. It says this type enumeration specifies the different types of status that an I2C request will have. These are self-explanatory. We've got the message complete, the message fail, the data no acknowledgement, the lost status. We've got other functions like the I2C initialize. We've got the master write to send the data to the I2C bus. We've got master read and so on. So this is easy to use. So we're gonna use this library in this application. The other thing we need to configure is the USART module, so we can display our temperature on the USART terminal. Under the USART, we're gonna use the USART 1. We're gonna enable the USART. The baud rate, we're gonna leave it at 9600. We're gonna enable the receive. We're gonna enable the transmit as well. And lastly, we're gonna redirect STDO to USART. This is gonna enable us to use the formatted output functions such as the printf. Let's check pin module. We've got all our pins configured with MCC. We've got RC3 is our clock pin, RC4 is data pin, RC6 is gonna be output TX pin, and RC7 is gonna be RX pin. Generate successfully. That's write a simple code that is gonna display the temperature on the USART terminal. It's really easy to use the TC74 temperature sensor. We've got only two registers, the read temperature register and the read-write configuration. In the temperature registers, each unit represents 1 degree Celsius. So it's really simple. If we receive, let's say 0, then the temperature is going to be 0 degrees Celsius. The most significant bit is the sign bit, which is set for 1 for negative temperatures. So therefore the maximum measurable temperature is going to be 127 degrees Celsius. For the negative values, this is going to be a 1. The other TC4 register is the configuration register. This is also an 8-bit read-write configuration. It's used to put the device into a low power standby mode. Typically the current consumption is going to be 5 microamp. In this mode, the analog to digital converter is halted and the temperature data registers are frozen. Bit 7 of this register must be set to 1 to put it in standby mode. The default address of this sensor is 1001101, which is 4D in hexadecimal. However, there are other 7 addresses options that are available, which can also be identified from the part number of the device. These are the steps to read the temperature from this device. The host microcontroller will issue a start condition followed by the address byte of the sensor. The address byte consists of a 7-bit slave address and a read-write bit. The read-write bit is always 0 to write in the first phase. The sensor will respond with the acknowledgement if the received 7-bit address matches with its own slave address. Then the host microcontroller will send the command byte to the sensor to indicate which register it wants to access. For reading the temperature, the command is going to be 0. To put the device in standby, the command is going to be 1. And the sensor will respond with an acknowledgement pulse. Then the host microcontroller will issue a new start condition because the direction of the data transfer is now going to be changed. The new address byte with read-write bit 1 is sent, which is acknowledged by the slave. Then the sensor will transmit the 8-bit temperature data from the temperature register. Upon receiving the byte, the microcontroller does not acknowledge but generate a stop condition. The first thing, we're gonna declare the slave address. We read from the data sheet that the default address is gonna be 4D. We just declared a sign variable to hold the sign of the temperature if it's a negative or is a positive temperature. The MCC I2C master driver based on interrupt driven state machine designed to perform small I2C transactions automatically. This can be queued to obtain custom sequence as required by each specific application, like for example a master write followed by a master read. So we must enable the peripheral and the global interrupt. Failure to do so, the I2 driver state machine won't be able to advance. Okay, so this is a simple function that we have created to read the temperature from this sensor. Okay, the first variable, this is just gonna be a buffer for a read value. We are using the keyword volatile to tell the compiler that this variable can change its content outside the normal flow of the program, usually due to an interrupt or hardware source. The second variable, this is just gonna hold the command that we're gonna send to our sensor. The value of 0 is to access the temperature register, and the value of 1 to access the configuration. The status variable is going to hold the current status of the I2C queue. The API internally contains a queue of I2C requests to perform and operate on this queue according to the interrupt from the MSSP peripheral. Once you call the function, the request is added to the queue to be processed when available. If you need data from the slave or want to make sure that data is received, you can wait until the status variable changes from pending. The first step we're gonna do, we're gonna send the command, which is gonna be the data to read the temperature. The length is gonna be 1. Then we're gonna send the address of the I2C, which is gonna be 4D. Then we're gonna wait while the status is still pending. When this status changes to complete, it's gonna exit this while one loop. Then the next I2C command is gonna be now to read from the device. We're gonna store the 8-byte variable in this variable. The size is gonna be 1 and the address of the device. And the status, we're gonna wait again while this queue is being processed. Then we're gonna check if temperature is greater or equals to 128. It's basically that we've got a negative temperature. We're gonna change the temp sign variable to 1 to indicate that is a negative temperature, or else we're gonna set it to 0. Then in our while one loop, we're gonna read the temperature continuously. So we're gonna call this function. We're gonna check if the temperature is negative. We're gonna print a negative sign. Then we're gonna display the temperature. Otherwise, we're just gonna display without a sign. And after 1 second delay, the loop is gonna repeat again. Let us build. Build successful. Run simulation. Great, we can see it displaying the temperature 27. Gonna try to increase it. It's gonna be display every second. Can also decrease it. Let's go to minus 5 degrees and so on. So basically this is really easy to use this sensor. Let us analyze the I2C data that we are receiving. To do this, we're gonna need an I2C protocol analyzer. The clock be connected to clock line, and the SDA is gonna be connected to the SDA line. If you right click and click on help, it's gonna show you how you can use this protocol analyzer. Basically the S is denote the start condition, the P is gonna be the stop condition, the N is gonna be a negative acknowledgement condition, and the A is gonna be the acknowledgement condition. Gonna run again. Pause the simulation. Let us analyze the data. So to read the temperature byte, the first step, the master is gonna issue a start condition followed by the address bit of the slave. In this case, it's gonna be our slave address. It's gonna be 4D plus the read write bit, which is gonna be 0 to write first to the register. It's gonna be 9A. Then the slave is gonna respond with an acknowledgement, which is A. Then the master is gonna send the command bit to select which register is trying to read from. The temperature register is 0. Then the slave is gonna respond with an acknowledgement. Then the master is gonna stop. It's gonna issue a new start condition followed by the address bit. In this case, now to read, it's gonna change from 0 to 1. It's gonna be 9B. The slave is gonna respond with an acknowledgement. Then the slave is gonna send the data byte read from the register. Here we receive FD. FD is gonna be 253. It is gonna be 256 minus 253 is gonna give us minus 3 degrees Celsius. then the master is gonna issue a stop condition. And that's all guys for this tutorial. It's very easy. As we can see with MCC, it simplifies everything. Just have to remember that this library is based on interrupt driven state machine. So if you forgot to enable your global interrupt and peripheral interrupt, your I2C bus is not gonna work. Thank you guys for watching. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. If you've got a question, you're welcome to leave your comment. If you need to learn more about this project, please click on the link in the description of this video. It's gonna take you to our website where we explain this project in details. And I'll see you guys in the next tutorial. Thank you.